Welcome. In this video, we're going to explore essential best practices for Node.js security. Securing your Node.js applications is crucial to protect user data and maintain the integrity of your system. Let's dive in and learn how to build more secure applications. First, let's talk about input validation and sanitization. It's extremely important to validate all user inputs to prevent malicious data from entering your application. Here is how you can use Joy library to validate user input. First, require the Joy library. Then, create a user schema object with validation rules. Here, email is validated as a string and is checked to be a valid email. Also, it is marked as required. The password field is also validated as a string, with a minimum length of 8 characters, and it is also marked as required. Finally, validate the request body against the user schema. The validate function returns an error object and a value object, which we can use to handle validation errors and access the validated data. Now let's discuss secure authentication. Passwords should always be hashed before storing them in the database. Here's how to use bcrypt for password hashing. First, require the bcrypt library. Define the number of salt rounds for bcrypt. A higher number means more secure hashing, but it also takes more time. Hash the password using bcrypt's hash function, passing in the password and the number of salt rounds. To verify the password during login, use bcrypt's compare function to compare the entered password with the stored hash password. This function returns a Boolean value indicating whether the passwords match. Next, let's talk about environment variables and secrets. Sensitive information, such as database URLs and API keys, should never be hard-coded in your application. Instead, store them as environment variables. Here's how to use .env for configuration. First, require and configure .env. This loads environment variables from a .env file. Access environment variables using process.env followed by the variable name. It is important to never commit to env files to version control to prevent exposing sensitive information. Let's see how we can prevent SQL injection. To prevent SQL injection attacks, always use parameterized queries or object relational mappers. Here's how we can use parameterized queries. First is an example of code vulnerable to SQL injection, constructing a query by directly embedding the user ID. Instead, use parameterized queries. The question mark placeholder represents a parameter that will be safely inserted. Pass the user ID as a parameter to the query function. Or use named parameters. Provide an object where the keys match the parameter names in the query. These methods ensure that user input is properly escaped, preventing SQL injection attacks. Now let's discuss HTTPS and security headers. Always use HTTPS to encrypt data in transit. Additionally, implement security headers to protect against common web vulnerabilities. Here's how to use Helmet to implement security headers. First, require the Helmet library. Then, use the Helmet middleware to apply various security headers. These headers include Content Security Policy, HSTS, which is HTTP Strict Transport Security, No Sniff and Cross-Site Scripting Filter. These settings help prevent common attacks like cross-site scripting and clickjacking. It is very important to always use HTTPS in production to ensure data is encrypted during transmission. Now, let's learn about rate limiting and distributed denial of service protection. Implement rate limiting to protect your application from denial of service and brute force attacks. Here's how to use Express Rate Limit. First, require the Express Rate Limit library. Configure the rate limiter with options such as window milliseconds, which defines the time window for the rate limit. Set max to the maximum number of requests allowed per IP address within the window. Customize the message sent when the rate limit is exceeded. Finally, apply the rate limiter middleware to your application to enforce the defined limits. Let's explore dependency security. Regularly audit your project dependencies for vulnerabilities. Here's how we can use npm security audit. To check for vulnerabilities, run npm audit. To automatically fix issues, run npm audit fix. To force fix all vulnerabilities, run npm audit fix force. Use npm CI for production installs to ensure consistent and secure dependency versions. Keeping your dependencies up to date helps protect against known vulnerabilities. Now let's talk about error handling and logging. Implement proper error handling and logging to help identify and address security issues. Here's how to do secure error handling. First, require a logging library like Winston. Use a global error handler to catch unhandled exceptions. Log the error stack trace for debugging purposes. In production, avoid leaking sensitive information by providing a generic error message to the client. Customize the error message based on the environment. Finally, send a 500 internal server error status with the error message as a JSON response. Let's summarize the security best practices we've discussed. Always validate and sanitize user inputs. Use bcrypt for password hashing. Keep sensitive data in environment variables. Protect against distributed denial of service and brute force attacks using rate limiting. By implementing these practices, you can greatly enhance the security of your Node.js applications. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.